In this video, we're going to go ahead and practice graphing a rational function together. Now, if you'd like to do this problem with me using the same PDF, you can find a link to that below. Let's get started. All right, so the first thing we're going to want to do with these rational expressions is try to factor it. So the top is actually going to factor quite nicely. I'm not going to spend too much time talking about how to factor. If you need to refresh your memory on how to factor, then you can go ahead and check out one of my previous videos. But this top is actually going to factor nicely into this x minus 5 times this x minus 5. It's what we call a perfect square trinomial. And on the bottom, I believe this is going to factor into 2x for the first one, then 1x in the second one. And I think we're going to put a minus 5 over here and a minus 1 over here. So again, if you need to think more about that, then go ahead and pause and do so. This is actually really important to do because sometimes you will find a hole when you go ahead and factor. So in this case, we do see that, hopefully, because we can see this x minus 5 and x minus 5 are going to cancel out. And that tells us that we will indeed have a hole for this rational function. So on top, we're going to be left with this x minus 5. That's going to be our expression in the numerator. And in the denominator, we have this 2x minus 1. Now, it's important to know that this canceled out, so it's missing from our function now, but that means that there was a hole located if you just set that expression equal to 0. So if you set x minus 5 equal to 0, add 5 to both sides, we now know that at x equals 5, there is going to be a hole for this function. So we know that there's going to be a hole in this function when x is equal to 5, but where exactly is that hole? Like, what's the y value that goes with the x value? Let's go ahead and just take that 5 and substitute it in where we see x in this expression. So on top, we're going to have this 5 minus 5, and then on bottom, we're going to have this 2 multiplied by 5 minus 1. Now 5 minus 5 on top is 0, and then 2 times 5 is 10, minus 1 is going to be 9. So in this case, it just happens to be 0. So again, at this x equals 5, we know that there is going to be a hole, and the y value where the hole is going to be at 0. So putting that together, we know there's going to be a hole at 5, 0. All right, let's go ahead and take that information and just put that in our chart here. I'm just going to go ahead and highlight so we have the same exact colors here, but our hole is going to be at 5, 0. Happens to be on the x-axis. Alright, now that we have our hole, it's time to go on and take a look at maybe some x-intercepts or y-intercepts. So let's see, let's go ahead and take this simplified rational function that we just have over here. Let's go ahead and just rewrite that. So we have this f of x is equal to, and it's simplified down to this x minus 5 over this 2x minus 1. Now, to find the x-intercept, remember that we find x-intercepts when y is equal to 0. Remember, f of x is really just the same thing as y, essentially. So if we say that y is going to be 0, we're going to say f of x is equal to 0. And that's going to be equal to this expression of x minus 5 over this 2x minus 1. Now, the left side of this equation is equal to 0, so how could the right side equal 0? Well, try to remember that anything divided by 0 is going to be 0, right? So if we can get this numerator to equal 0, then that is where the x-intercepts are going to be found. So if we go ahead and say that 0 is equal to this x minus 5, then go ahead and add 5 to both sides, we're going to find out that x is equal to positive 5. So we typically would have an x-intercept located when x is equal to 5, but try to remember that we actually found out that we had a hole here at x equals 5, so we're not actually going to have an x-intercept here. So that being said, let's go down here and kind of get that charted up so we know that's what we're going to be saying. So for the x-intercept, we were going to have one, but we found out that there was going to be a hole there. So we're going to say none for this one. There's going to be no x-intercept for this particular function. Let's take a look maybe at the y-intercept now, right? So for the y-intercept, that's when x is equal to 0. So to find the y-intercept, that's just when x is equal to 0. So notice here in the function, this is x and this is x. We're going to go ahead and substitute in 0 for that, right? So let's go ahead and say that we have this f of x. That's going to be equal to what? If we substitute in 0 in for x, it's going to be 0 minus 5 over 2 times 0 minus 1. Now 0 minus 5 on top is going to be negative 5, and then 2 times 0 is going to be 0 minus 1 is going to be negative 1. So negative 5 divided by negative 1 is going to be a positive 5, right? So that was when x was equal to 0. We found out that y was equal to 5 here. So we're going to go ahead and say that this point is going to be 0, 5, right? We just said when x was 0, we found out f of x, or y, was equal to 5. So this right here would be our y-intercept. Let's go down to our chart and see if we can go ahead and put that in there so we know what's going on. So I'm going to go ahead and use the same color. This is our y-intercept. I think I did that in green. So we're going to say our y-intercept here is going to be 0, 5. coincidence that it's similar to our whole. All right, let's now move on to some asymptotes. So let's start with maybe the vertical asymptotes. I think this is a good one to start with. So these are going to be some vertical lines that this graph is not going to be able to touch. So the vertical asymptotes are these imaginary vertical lines that let us know what x values we can't have because the denominator is going to equal 0. Remember, we can't divide by 0 because that's going to cause a problem. So we just need to make sure we know when the bottom of this is equal to 0. So for this vertical asymptote, we're going to take the denominator here of this 2x minus 1 and set it equal to 0. So we find out when it equals 0, that's when we know we're going to have a vertical asymptote. Let's go ahead and add 1 to both sides. If we do that, we're going to get 2x is equal to positive 1. Then divide both sides by 2, and we find out that x is going to equal to 1/2. All right, so if x is equal to 1/2, and we plug that into our function here, we're going to find out we're going to get 0 in the denominator, and that's no good. So we know we have a vertical line at x equals 1/2. So let's go ahead and write that in here. Our vertical line here is going to be x is equal to this 1/2. All right, what about the horizontal and slant asymptotes? Well, let's go ahead and take a look maybe at the horizontal one first here. So we're gonna have either or, horizontal or slant. So let's go ahead and see what's going on here. So for the horizontal one, let's go ahead and see. We have to look at the degrees of these expressions in the top and the bottom. So notice how the top leading term has a highest degree of 2, and on the denominator that also has a highest power of 2, so they're tied. Whenever they're tied like this, you just go ahead and take the ratio of their leading coefficients. Now there is an invisible 1 in front here, that's 1x squared. So we have a 1 here and we have a 2 here, right? So if we're going ahead and doing this horizontal asymptote, we really have to just take a look at those two values here. We have this 1 and we have this 2, all right? Or you can think about it over here, we really have a 1 here and we have a 2 here. So for the horizontal asymptote, we're just going to say it's the ratio of that. So we're going to say that that is going to be y is equal to, because again, it's a horizontal line. So if you have y is equal to 1/2, that's going to be a horizontal line. So let's go ahead and write that into our chart. For this particular rational function, we're going to have y is equal to this 1/2. So again, it just happens to be also 1/2, which matches our vertical asymptote, just kind of a coincidence for this problem. Finally, let's take a look at the slant asymptote. This is only going to happen in very specific scenarios, and that's going to be when the degree of the numerator is just exactly 1 higher than the denominator. So this 2 and this 2 match, so that's not going to happen in this case. It's only going to happen if the top degree is exactly 1 higher than the bottom degree. So in this particular case, we're just going to go ahead and say that there's going to be none here. And that makes sense because we had a horizontal one, so we're not going to have a slant asymptote. Okay, so now let's go ahead and see if we can start graphing and put all of this together. Typically when you're graphing, you're going to start by putting asymptotes down. So let's start with the vertical asymptote here. If we go ahead and do that, we know x is equal to 1/2. So that's going to be this vertical line right over here, x equals 1/2. Just go ahead and label it. Now let's go ahead and take a look at our horizontal asymptote, and that's going to be at y equals positive 1/2. So right there is going to be our horizontal asymptote. And we don't have to worry about the slant asymptote because we don't have one for this particular function. Okay, now moving on to the x-intercepts, we don't have any, so we're going to go ahead and just leave that alone. For a y-intercept, it's going to be at 0,5. I'm going to go ahead and plot that right along the y-axis, right at 0,5. And then we're going to go ahead and see that we have a hole here located at 5,0. At 5,0, I'm going to go ahead and put a hole and just leave that open. So that's all the important information that we knew from what we just found. And hopefully it makes sense that since we have this point of 0,5 and 5, 0, this hole here, that the location of this function is going to look something like this, where we have a curve in this part of the graph. We're going to have some curve looking like this over here. Hopefully if this looks familiar, then that's good. I'm going to go ahead and make a quick table though to give a little bit more clarity on how we would know that if you just wanted to be a little bit more clear, right? So we're going to go ahead and make a quick XY table, but we're going to stay away from the vertical asymptote and stay away from this x equals 1/2. So we're going to pick some x values that are maybe to the left of it, and then we'll pick some x values to the right of this 1/2, anything over here maybe. Okay, so let's go ahead and do that together. So let's go ahead and do a quick XY table. All right, so first I'm going to go ahead and just try something like -1. That's definitely going to be to the left here. So if we go ahead and take a look at our function, I'm actually going to go ahead and see if I can bring that down. So I'm just gonna go ahead and take this function here and copy it so that we know what to do. So I can see that a little bit more clearly without scrolling back and forth here. All right. So if we go ahead and take this -1 and plug it into x here, so we're gonna plug that in right over here. So 1 times -1 is just -1, minus this 5, that's going to be -6 on top. And then if we take that -1, plug it in here, 2 times -1 is -2. -2 take away 1 is -3. So we have -6 over -3. And that's going to equal +2 here for the y value, okay? So we know that when x equals -1, then y is going to equal this +2. So at -1, +2, we can go ahead and plot that point on our graph, okay? I'll do one more point on this side maybe, or two, we'll see. I'm going to put in this x equals -2 here. So we'll take this -2 and plug it into our function here. 1 times -2 is -2, minus the 5 is going to be -7. So on top, we're going to get -7. And on bottom, we have 2 times this -2, which is -4. -4 minus 1, that's going to be -5. So this is going to be what? +1.4, or 1 2/5. Okay, so I'm going to go ahead and say it's +1.4, but feel free to use the fraction if you want instead. -2 comma 1.4 would be somewhere like this, a little bit less than half a box up from between 1 and 2. All right, I think this is pretty good. I'm not going to go ahead and go too crazy with this. I think that is pretty good on this side. So if I were to sketch this part of the graph, it would look something like this. All right, so there is a rough sketch on that part of it. And let's go ahead and choose some x values that are on the other side of this dotted line. So maybe we can choose something like x equals +1. Let's choose some nice, easier numbers to do. So we take this 1, we plug that in here. 1 times 1 is going to be 1, minus the 5 is going to be -4. And if we plug in that 1 on bottom, 2 times 1 is going to be 2, minus the 1 is going to be 1. So we have -4 over +1, which is -4, right? So when x is 1, y is going to be -4. You can go ahead and plug that in. So 1 comma -4 would be this point down here in quadrant 4. All right, I'll do maybe 1 or 2 more points here. We can say x is equal to 2. So we can take this 2 and plug it in right over here. So 1 times 2 is 2. Minus the 5 is going to be -3. So we'll have -3 on top. And then we have 2 times 2, which is 4, minus 1 is going to be 3. So we're going to have -3 over +3, which is just -1. So when x is 2, y is -1. Let's go ahead and plot that on our graph here. 2 comma -1, and it would be somewhere just like this. Now, feel free to go ahead and make some more points, but I think at this point, I know what my graph's going to look like, so you should see how many points you need to maybe put, but I'm going to go ahead and make a curve now. All right, so again, just a rough sketch, but this is what our rational function would look like. Now again, if you wanted to go ahead and make it more detailed, you just keep making up more x values to the left and to the right of that vertical asymptote, and you'll have more points to kind of connect and make a more accurate sketch. But I think this is a pretty good and accurate sketch for this rational function. So that just about wraps up this video on how to get all the important points for a rational function, as well as going through the process of graphing it and making a quick table just to get a little bit more accurate sketch going. So hopefully you found the video helpful. If you did, please consider giving the video a thumbs up and sharing it with a classmate or friend who might also find it helpful. And as always, keep up the great work that you're already doing, and I'll see you in the next one.